Hello all, this is Chris from Props3D and I have a problem. A problem I'm hoping we can solve together over the next few videos, and that problem is audio in props. Check this out. This is my as yet unreleased Mandalorian blaster. It has what I consider my basic audio setup, which is a 2.5 watt amp, a 2 watt 40mm speaker, and a DF Player Mini MP3 player. And it sounds like this. Considering the teeny little space, I think this sounds awesome. Now let's compare that to this. This is an SE14R. It has the exact same setup, except the speaker is in the cap and the entire body is a cone. And listen to this. This one actually hurts my ears if I have it up here. It is freaking crazy. Same speaker, same amplifier, same battery, same buck converter, but this one is easily twice as loud. And now let's compare it to this little guy. This is the bare speaker with the same components and sounds terrible. What should it sound like? Whoop! Man, I'm gonna clear all my blasters out before this video even starts. It should sound like this. See the problem? So let's find out together how much a speaker enclosure really matters. Before we're going to get into how to test this in the setup, I want to show you the two end goals of this. The first is very small. This is the Dredd Lawgiver I'm working on. It has been an incredible journey to get this point, and at the very end, or what I thought was the very end, I ended up with this. I have to hold this down here. This is the trigger, which is going to simulate the DNA test. Oh. And I'm not even sure if the mic is picking this up. Hot shot. That one's quite a bit louder. Incendiary. Yeah, that ain't gonna do. The second, which is the large goal, is over here. And this is the big project. This is the Toy Trader's R2D2 that sits stoically at the front of the store. And stoic it is no longer, right R2? Exactly. By the end of this project, this thing is going to have the largest sound system I can cram in it to be heard from one end of the store to the other. What do you think about that, R2? Exactly. So let's get going. So let's go through our testing setup. First, I have modeled 5 potential speaker enclosures, the most minimalistic of which is the stick. This is basically a speaker stuck on the end of a stick. See how that works? Who knows? Next is a bit of isolation. The speaker is going to be mounted in the back of this as soon as I rip off the support material, and hopefully it'll give it a bit of resonance attached to the board and a little bit of isolation so it'll thump a little harder. Next is a more traditional speaker setup. It has a bit of separation between the intake and, well, it's not an intake per se, but essentially it equalizes the pressure as the speaker goes back and forth. And it has a back that goes on there and a little stand. It looks like a speaker. See if it works like a speaker. Not this one, this one. Next we have a long tube. This is a very long tube, and that's what worked on the other blaster. Let's see what happens. And finally, we have the wacky option. I Googled around and I found some audiophile forums and I found some crazy designs. I took the one that everyone seemed to like and I sort of, let's say, made an inspired model from that follows the same kind of pattern where we have the speaker in the front up here, and then the sound will have to travel all the way through there, or the pressure, sorry, not the sound, and out the bottom. And I don't know. I have high hopes for this one. Who knows what's going to happen. For the speakers themselves, I have a whole bunch of the basic speakers. Basically 8 ohm, 2 watt speakers. These are the basic speakers that have worked awesome for me in the past, and you know, they're all the same, so it's going to be down to the enclosure, not to the speaker. And as to the setup, I have my ye old basic prop sound setup with the subtraction of the Arduino. I have the DF Player Mini MP3 player on there with a blaster sound. I have a 2.5 watt amplifier and a 5 volt power supply. That's it. You know, you push the button, it makes a sound. Doesn't get simpler than that. First thing we have to do though is take some of these speakers and solder wires to them. So I guess I'm getting up again. All right, let's head inside. All right, now with that out of the way, and hopefully the last time I'm going to have to get up in this video, we have our 1, 2, 3, 4, 5 speakers. Let's get them installed. First, I'm going to take off this support material, grab a little knife, and oh, I guess it just pulls off. Ooh, a little printing flaw there. I don't think it'll affect anything. All right. Always shake your super glue. There it goes, thickens up. Gonna make sure there's no gaps here, so we have nice sound isolation and a nice bond. That looks very nice. Stick that down. And there's the first one. Actually, the second one, I'm gonna get the stick. You'll see why in a second. And then run the bead. Oh, actually, just because I know I'm gonna bung this up, I'm gonna go like that. Put it through here. Couple little gaps. Very good. I'm going to lower this in. There, I'm going to push that down. And I'm going to grab a bit of tissue, wipe that up. This cutting mat does not like super glue. It stains it like you wouldn't believe. There we go. I'm going to run a little lip around the top. Boop. Wipe a little excess off. Go down there. Perfect. Oh, this one actually has some screws in it too. Forgot about that. There, just gonna grab There we go, M4 tap. This is an electric screwdriver with a chuck on it. This is brilliant for 3D printing because it's not as aggressive as a full-size drill and is very unlikely to damage your prints. There's one. Now I can do the other three nice and comfortably. Perfect. That's two. And now this guy. Made this little teeny hole here where these wires can go through. Whoop. And we'll do the same glue treatment. All right. There, put the back on. There we go, and there we go. That's number three. This one is easy. Whoop. And peel that, stick that. And that's it. All right, and now for the last one and the most complex. I made this almost support free, but there was a couple of places where I couldn't avoid it, like on the little lip. There. And around the face. Try to pull it off this time. There we go. So in order to keep this support free, I had a bit of an interesting idea of doing the speaker mount as a separate object. So you can print it flat, slide it in, and then you don't have a weird hole from having to print it vertically. Actually, I don't want that vertical. Through as well. Then we can slide that through. There we go. There. Then this one is a little different actually. I thought we'd use set screws here, and whoa, stuck on the screwdriver. And the set screws would allow it to sit pretty flush. I'll show you what I mean. Oh, actually, you know what? I don't need to tap the entire side. I'll show you why in a sec. Oh yes, I do need to tap the inside. Ugh. So if I was using a screw, I wouldn't, because the screw would pull together. But since I'm using set screws, I do, because the side is going to be part of what holds it together. The threads that are put in the side. Now we're going to push down on this, that way it'll create a decent seal. There's a little lip on the side that helps it actually seal a little better. So I don't really think I need to actually seal the two halves together with tape or glue. I'm just going to try to leave it like this and see how that works. That looks much better. There we go. That's 5. Now, onto the test apparatus. We have a dB meter, which we are going to set to max, which will then record the loudest sound it hears. And then we have a Zoom H5, which is manually attenuated. This way it won't adjust the volume depending on how loud things are, so you get kind of an honest impression of the sound. And the most important thing is the stick, which I am going to put from the end of the dB meter, which is going to give us an accurate measurement because everything will be the same distance. So let's get our little MP3 player. I have arranged these in my perceived order of how good they are. Let's get started. First thing we're going to test is speaker on a stick. We're going to plug it into our little improv blaster. Little DuPont connections don't want to go in. Set our distance. Reset the max. And let her rip. Oh, actually I shouldn't have said that so loud. And let her rip. 93 decibels, that is actually respectable from speaker on a stick, but it sounds terrible. Doesn't get any higher. Double check those distances. Maybe just let's make it really accurate. That's the most we're going to get out of it. All right, it is actually reasonably respectably loud, but it sounds like absolute garbage. I was going to say another word, but this is YouTube. We got to watch our P's and Q's. All right, next is speaker on a flat plate. I'm giving these really clever names. Okay, let's get this exactly correct. Reset our dB meter. In a way, this is the most interesting one because it's obviously the easiest one to build into a model. Ooh. Come on, 100. Oh, we broke 100. 102. Holy jolies, that is a big difference. Every 10 on the dB scale is 10 times louder. So this is way louder. 103.5. And I can actually hear the high range a little bit, and not much bass, but there's a bit of high range in there, which was completely missing from speaker on a stick. So this is a massive improvement. I'm liking it. I mean, it's still not amazing, but it's like a huge improvement. So we got 103.5. So let's go with the traditional speaker design. Traditional speaker, what do you have for us? Oh, I'm going to reset the max. All right, here we go. That's pretty much functionally exactly the same as speaker on a stick. The sound is nice. It's got a nice low range, but it's missing the high range. It's like, this is a woofer and this is a tweeter. That's kind of whack. Oh, I can hear the high range. You know what? The quality is definitely better than plate speaker, but the sound is like 10 dB quieter. That's almost 10 times quieter. That's crazy. I mean 10 times by the dB scale. By the perceptual scale, it's noticeably quieter, but it's not quiet or anything. Crazy. Okay. Well, let's go with the big tube speaker. This is another really interesting one because the loudest blaster I made was in a big tube. So it stands to reason that this is going to be the loudest. Ooh, there's a little interference coming. That's the problem with using these little test boards is you get interference. Oh, see? Kind of went away. We're just going to ignore that. Once you solder things up in a circuit, all that goes away. All right. Then, come on, 105. 102.9, we've tied. That's odd. It's got a lot more bass. It's a little echoey, so it's not a great sound, but it's definitely thumping. But it's not quite as loud. I mean, it's almost equivalently loud as Speaker on a Plate. All right, let's just go right. Oh, that's exact. That's brushing it. Well, go figure. Speaker on a Plate is louder. Moving along. All right, for now, the crazy design. This is taken off a audiophile forum where they were discussing the best quality sound for a speaker, and I totally borrowed a few ideas for this one. Oh, and I totally didn't mention all of these designs. They're gonna go onto Thingiverse with this video, so you can download these, play with them yourself, make yourself a little stereo. It's up to you. Have fun. Oh, that's fine. It's gonna be over that. Oh, that's not bad. It's not over 100 dB. That's really good quality. That's like a full range speaker there. This is the first one I would say is a full range speaker. Like there's nice mids, there's nice highs, there's nice lows. It's not breaking 100 dB, which is sort of surprising, which I guess the little speaker didn't. So maybe something about having it in enclosure makes it quieter? Color me surprised. Wow. Okay. Well, there's your result. This isn't as loud, but this is crazy good quality. No, I'm not getting over that number. That's the final number. And there we go. Okay, so now I'm going to lay these out in loudness level and then my quality level. And let's, from what I heard. And let's see how they rack up. So unsurprisingly, in last place in every category, we have Speaker on a Stick, the quietest speaker with the worst quality. And next, weirdly, they're sort of a tie, they're a functional tie, but we have traditional speaker, and then we have kind of cool design speaker. These were almost equivalently loud. And then in the loudness scale, almost a tie again, we have big tube and the plate. So that's kind of cool. So we have absolute trash, definitely best sound quality, and the loudest one. So if I had to arrange these though in the design I would pick in a prop, I would totally go at number 1, this guy. Best sound quality by far. Next, this would be a toughie. Honestly, I would have to go with the Canon. I got good sound out of that and it was really loud. Followed by traditional speaker. Followed by the loudest one. Because loudness isn't everything. If it sounds like a blunt when it makes a sound, it doesn't sell, right? So I will definitely put this in 4th. And unsurprisingly, we got Speaker on a Stick taking up last place and everything. So thank you all for joining me on this wild and wacky and hopefully informative journey into speaker enclosures. Next week, over there, I have a huge pile of random speakers to test out. We are going to be testing my common prop speakers, some really interesting alternative speakers, and some big ol' speakers, and seeing how they all sound in this enclosure. I'm going to print a bunch of these and let's see. Actually, you know what? I'm going to do this enclosure and I'm also going to do this enclosure because printing about 30 of these is going to suck. So thanks all for joining me and I will see you next week. Oh, by the way, don't forget to... Okay, I got a foot pedal down here and I'm always losing it. That was a bit of an exaggerated but I was stepping on the top. There we go. All right, so rewinding that. Thanks all for joining me on this little audio journey. And so if you enjoyed this video, I hope you'll consider giving it a like and subscribing for more Props 3D content. Until later, have an awesome time all.